Welcome to AP Physics 1. The purpose of these videos is to help you out in case you get stuck. Today, we're going to be focusing on part 5. My favorite part, graphing. So let's jump right in. Graphing is an integral part of physics. In fact, I would say it's one of the major parts that we're going to be covering because it is the best way to show relationship between variables, which really is the whole purpose of the class. We're going to be analyzing different variables and how do they interact. With every graph, I am really expecting 5 major components. Now, in this case, we don't have a title, but let's just walk through this. The first one and most important is a label. This is not math class. If you don't have a label, it's just math. It has no significance, no relationship, no nothing. So you have to have a variable. Kind of along the same line of thought there. Units. Without units, again, it's just a bunch of numbers on a page. Doesn't really matter. A title, again, not critical, in case here we don't really have space. I'm not going to try and write in there. But for the most part, it's going to be Y versus X, kind of quickly identify what it is you're presenting. And number 4, though. Number 4 is something really, really important I really want to address. Proper scale. In order for a graph to be true and actually show the relationship between the variables, you have to be consistent with your scale. For example, down here, have every box is half a second. Now, if you had every box as 1 second, that's totally fine too, right? You'd probably have a lot of extra white space, but that's okay, as long as you're consistent. What I see happen a lot, for example, is along the y-axis, here we have velocity, people will post these data points on every box, where they'll say, all right, the first box will be 32, then 63, then 97, but that's not correct because you have to be consistent, right? If you had every box be 32, okay, that's kind of weird, but that's fine, but that means that you should be going down here would be 32 and then 64, right? How you have to keep going like that, not 63. So that's where things get a little tricky. Make sure you have proper scale. The last thing here is line of best fit. So I went ahead and I plotted out the data. I got my proper scale, labeled, units, everything. But now we're going to go ahead and make a line of best fit. And assuming 0, 0 is a data point, we can go ahead and trace this out. Please use a ruler when you do this. As you can see here, this is not the best. But you get the idea. Make sure it connects through as many dots as possible. Now, that's a common thing. How do I make a line of best fit? Well, you want to minimize the distance between the dots. So it might not always start exactly at 0. It might not hit the most amount of dots as long as you're minimizing the distance between the points. We're going to do a lab on this on the first day of class, so we'll really kind of highlight what I mean by that. One thing to point out is that a line doesn't have to be a straight line, right? It could be a curved line. So just keep that in mind. Hint, hint number 2. Also, typically on a lab, you'll be trying to identify which variable is independent and which variable is dependent. Like, what are you manipulating? What is being affected by your manipulations? However, in this problem, it's given to you. Velocity is on the y-axis, making it our dependent variable, and time is on the x, making it our independent variable. So now we'll go ahead and answer these questions. Number 2, what kind of curve did you obtain? We obtained a linear curve. That's kind of a weird thing to think about, but yeah, a curve could be a line. What is the relationship between the variables? Direct, inverse, or inverse square? Well, as you can see, as our time went up, velocity also increased. So let me just write this down here. So first off, linear and direct. And then finally, calculate the slope of the line. The way you do that is just rise over run. So here we're going to pick 2 points, and we're going to find the change in y over the change in x. So we say slope is equal to rise over run, or delta y over delta x. Now, you can never have a slope without 2 points. So even though 0, 0 was a point in this case, it might not necessarily be the case. The velocity might not be 0 at time equals 0. So just pick any two actual data points you have. Don't assume 0 and to calculate the slope. So in this case, we're going to pick just 32 and 1, and then we're also going to pick 225 and 7. So the difference here, we're going to get 225 minus 32 comes out to be 193 divided by 6. So over these 7 minus 1, so over these 6 seconds, we went 193 feet per second in increase in speed. So 193 divided by 6, we end up with 32.2. And the units for that, well, if we're doing delta y, the units are feet per second, and for delta x, the units are seconds. So we're going to get 32.2 feet per second, or feet per second squared, if you want to think of it that way. All right, so if you have any questions on number 2, please just send me an email or a mind chat. Otherwise, we will be having a quiz on day 3 of class. So make sure we're getting this all completed and understood. Good luck.